Hey everyone, welcome back to another video where I'll be teaching math. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. This is episode 4 of our playlist on definite integral as a limit of a sum. In the previous episodes, we have gone deep into the concept and solved a few problems. In today's episode, we are going to tackle a specific problem from JEE Advanced 2016 which appeared in the second paper of its mathematics section. JEE Advanced 2016 was by far the toughest JEE exam to date. The paper was super well set with notoriously difficult questions. Now there are two main ways to make a paper tough. First, you can make the questions really long and calculations super cumbersome. And second, you can make the questions more conceptual and tricky. This paper did both. And the question we will be solving today is known for being one of the most challenging questions ever to appear in JEE. It is a prime example of how perfectly concepts can be blended to create such a beautiful yet difficult question. There are a lot of small details we need to pay attention to while solving this. With all that context in mind, let us dive in and break it down step by step. But before we jump into solving, I strongly recommend you pause the video here and give this question a sincere shot on your own. Trust me, this video is going to be on the longer side, but that's because this question deserves all the time and effort. Make sure you stick around till the end to get the full understanding. Let's get started. So now you have this crazy looking function, all right, and you have to find the limit to which this particular function approaches when n tends to infinite. So this is based on the concept definite integral as a limit of a sum. So we have this particular formula that we have derived in the first episode of this playlist. All right. Now let us make some observations. First observation. So it is given that n tends to infinity. This implies that n is a positive quantity. All right. And it is also given in the question that x is greater than 0. So every term in this particular function is a positive term. So this whole limit will tend to a positive quantity. Therefore, we can conclude that f of x is positive. All right. This is the first observation that we can make just by looking at the limit that is given to us. Now, let us break it down a bit more. So now you have this particular form of the limit where you have the sum of terms. There is a summation over here. But here you have, here all the terms are multiplied together. So here you have a product and here you have a summation. All right. So how do you convert a product into a summation? So the trick is to apply logarithm on both sides. Apply logarithm on both sides. And what is the reason? So we know very well that log of ABC is log A plus log B plus log C. So here you have product of terms, and when you apply logarithm, it becomes the sum. All right. So to convert a product into a sum, you have to apply logarithm. All right. Now let us go ahead. So let us do exactly that. Let us apply logarithm on both sides. Then we get log of f of x is equals to, so here log of limit, so logarithm of limit n tends to infinity is same as limit n tends to infinite log of the function. Alright, so our RHS will be limit n tends to infinite log, this is n to the power n, this is x plus n by 2. I'm just writing whatever is given in the question, nothing else, and so on, x plus n by n. And in the denominator you have your n factorial, and it is x square plus n square, x square plus n square by 4, and so on, x square plus n square upon n square whole power x by n. So now if you recall the concept of logarithm, log of a to the power b is b times log a. So now this whole quantity is your a and this is your b. So if you apply that formula, so this x to the power n will come here. This x by n comes here. Alright. So now we have this particular thing. Alright. Now let us simplify it further. So limit n tends to infinite x upon n times log of, so n to the power n is n multiplied by n multiplied by n in n times, by n factorial is 1, 2, 3, 4 and so on n. Alright. Now this can be, if you bring this n to the denominator, this thing can be written as, so you have n terms in the numerator and n terms in the denominator. Let us do one thing. Let us bring all these n's that you have to the denominator here. So then how do we write it? So all these n's will go away and you'll have 1 here, and here you have 1 by n, n, n and n. Alright, so you got n terms here. Now let us go ahead. So the first term is x plus n. So I'll rewrite this term as x plus 1 upon 1 by n. Alright. Similarly, I'll rewrite the second term as 1 upon 2 by n. I'm just bringing this particular n to the denominator. Alright. And so on, x plus n up, sorry, this will be 1 upon n. Let us do the similar thing with the denominator as well. So here we have x square plus n square. I am writing n square as 1 upon 1 by n square. And x square plus, this will be 1 upon 2 by n whole square. And so on. This will be x square plus 1 upon n by n whole square. Alright. So this is what we have got so far. Now let us consider this as A, this as B, this as C and this as D. Alright. Then we have something like this, log AB upon CD. So this looks like log m upon n. That will be log m minus log n. Alright. What is log AB? Log AB is simply log A plus log B minus log CD is log C plus log D. So it will be something like this. So what do we get? Let us split the terms. What do we get now? So this is limit n tends to infinite x upon n. So the first term will be log A. Log A is log 1, which is 0. The next term will be log B. So that will be log of this particular term. Alright. That is I'm using pi to represent product. Pi r runs from 1 to n x plus 1 upon r by n. Alright. So if you put r is equal to 1, you'll get x plus 1 by n. If you put r is equal to 2, you'll get x plus 2 by n. If you put r is equal to n, you'll get x plus n upon n. And this pi represent product of those terms. Now minus logarithm of this particular term. Log of, similarly, I'll write pi runs from r is equals to 1 to n r upon n. If you put r is equal to 1, you'll get 1 upon n. If you put r is equal to 2, you'll get 2 upon n. If you put r equal to 3, 3 upon n. And likewise, you'll get n upon n when you put r is equals to n. And this pi represents product again. Now, we have to take logarithm of this term. So, minus log of pi runs from r is equal to 1 to n x square plus 1 by r upon n whole square. I think this is understood. Now, let us simplify this further. Limit n tends to infinite x upon n. So, when you apply logarithm to the product of terms, let us say log of a, b, c, d, this will be log a plus log b plus log c plus log d. So, here also you have product of terms, something like a, b, c, d and so on, a1, a2, a3 and so on, an. So that will be log a1 plus log a2 plus log a3 plus and so on log an. So this particular quantity can be written as sigma r is equals to 1 to n. So we are converting, we have applied the log to the product and it got converted to the sum. So whatever we have discussed in the beginning of the video. So this will be r is equal to 1 to n log of x plus 1 by r upon n minus similar thing with this r is equals to 1 to n log of r upon n minus r is equals to 1 to n log of x square plus 1 by r upon n whole square. Alright. Now this particular x, so here the limit is on the n. So x is independent of the limit. So you can bring out x. So this will be limit n tends to. So you can bring out this x. So we have the x here. Now if you compare this with the result that we have, limit n tends to infinite 1 upon n summation r is equal to 1 to n f of r upon n. So this is also limit n tends to infinite 1 upon n and then you have summation and then you have some function where you have r upon n. And similar thing with this, limit n tends to infinite 1 upon n summation and then some function in r upon n. Similar thing with this as well. So we can rewrite this as, so for the first term, if you apply this particular formula, it will be integral 0 to 1 log of x plus, wherever you have r upon n, wherever you have r upon n, you have to put t. Alright. So it will be 1 by t dt. Since we have x here already given in the question, so we are using this particular, we are using t as the variable in the integration. Alright. Minus integral 0 to 1 log t dt minus integral 0 to 1 log t x square plus 1 upon t square dt. Alright. This is log of f of x. This is log of f of x. Log f of x. Now since the limits in all the integrals are same, so we can write all three integrals, we can club all three integrals into a single integral. Alright. So let us do that in the next So this will be log of f of x is equals to integral 0 to 1. So first will be log of x plus 1 by t minus log t minus log of x square plus 1 by t square. So you can apply logarithm formulas, and what you get is log of x plus 1 by t in the numerator, and the denominator will be t times x square plus 1 by t square dt. This is the integral that you end up with. And now let us take the LCM and then solve it, simplify it actually. So it will be tx plus 1 upon t times t square upon t into t square x square plus 1 dt. T square, this t and this t will get cancelled. So now you have integral 0 to 1 log tx plus 1 upon t square plus x, t square x square plus 1 dt. So this is log of f of x. Here the variable is t. So x is like a number here. Alright. So let us make the substitution. Tx is equals to sum m. Alright. Then x is like a number since t is the variable. So x dt is dm. So log f of x will be integral. When you put t is equal to 0, m is equal to 0. When you put t is equal to 1, m is equal to x. So log tx is m plus 1 upon t square x square is m square plus 1, and dt is dm upon x. Okay, we missed an x here. So here we have x times the integral. So here we have an x. So we missed it. So x. So now here the variable is m. So x is independent of m. So we can bring it out. So this x and this x will get cancelled. So log of f of x is simply integral 0 to x log m plus 1 upon m square plus 1 dm. All right. Now what can we do? How do we solve this integral? So let us go through the question once more. So this is the question that we have. All right. This is the question that we have. Let me paste it over here. So this is the question that you have. If you observe, here you have, in this option you have f dash of 3 upon f of 3. So it looks something like f dash of x upon f of x. Alright, even this looks similar, f dash of x upon f of x. Okay, so let's do one thing. Now let us differentiate this on both sides. So what is the differentiation of LHS? Log of f of x differentiation is 1 upon f of x times f dash of x. So whatever product we are looking for, okay, in the question, in the options, f dash of x by f of x, we got it here. All right. So how do you differentiate this side? So you have an integral, you have to differentiate that integral. So you have to use Leibniz rule. So simply put the upper limit into the integrand. So that will be log of x plus 1 upon x square plus 1, and now differentiate the upper limit, which is nothing but 1, minus, now put the lower limit into the integrand. So that will give you 0. So this is what we end up with. So f dash of x upon f of x is f dash of x upon f of x is this thing. So what is f dash of x? F dash of x is f of x times log of x plus 1 upon x square plus 1. Now, how do we proceed with the question? So let us look at the question once. Okay, this is the question that we have. Okay, now we have to in the first option we have to check whether f of 1 by 2 is greater than f of 1 or not. Similarly, here also there is a comparison. Here there is a comparison. So from this particular result, we can easily verify option D. So let's do that first. So what is f dash of x upon f of x? So that will be simply this quantity. So if you want f dash of 3 upon f of 3, that will be log of 3 plus 1 by 3 square plus 1, 9 plus 1. So that is log 4 upon 10. Alright. Now let us find out f dash of 2 upon f of 2. So that will be log of 2 plus 1 by 2 square plus 1. So that is 5. So this is log 3 upon 5. So this can be written as log 6 upon 10. Alright. So which one is greater? Log 6 upon 10 is greater than log 4 upon 10. So f dash of 2 upon f of 2 is greater than f dash of 3 upon f of 3. Therefore option D is not correct. Option D is incorrect. Now let us go ahead and check the other options. Okay. Now tell me one thing. When does f dash of x becomes 0? F dash of x becomes 0. That becomes 0 when x is equals to 0. Put x is equal to 0, this term will become log 1 upon 1. So this is 0. And also we cannot put x is equal to 0 because x is greater than 0 and it is given in the question. Let us analyze it a bit more. Apart from x is equal to 0, for what value of x this quantity becomes 0? This becomes 0 when x is equal to 1. When you put x is equal to 1, it will be log 2 upon log 2. So that is log 1, which is 0. Alright. So, okay. Now, what happens when x less than 1? When x less than 1, f dash of x is equals to, for x less than 1, x is greater than x square. Alright. So if you consider 1 by 2 is greater than 1 by 2 whole square. So when x is less than 1, x is greater than x square. So x plus 1 is greater than x square plus 1. So your x plus 1 upon x square plus 1 will be greater than 1. If you apply logarithm on both sides, x plus 1 upon x square plus 1 greater than log 1 is 0. So when x is less than 0, this quantity is greater than 0. We already derived at the beginning of the video that f of x is greater than 0. So this is greater than 0 and this is greater than 0. So f dash of x is greater than 0. When x is less than 1, so all these signs will flip like this. So this quantity will become negative and this is positive. So f dash of x is negative. Alright. So we have this particular analysis now. So let us draw the graph. So here you have x is equal to 1. When x is less than 1, f dash of x is greater than 0. And when x is greater than 1, f dash of x is negative. Alright. So now let us verify the options. First option is f of 1 upon 2 and f of 1. We have to compare these two. 1 by 2 lies here and 1 lies here. Okay. Now we have to compare these two quantities. Alright, f of 1 by 2 and 1. 1 by 2 lies somewhere here. So 1 by 2 and 1 both lies in this particular region. In this particular region, f dash of x is positive. Alright. What does this imply? If f dash of x is positive, that means that the function is increasing. Function is increasing. Alright. If the function is increasing, f of 1 will be greater than f of 1 by 2. But that is not what is given in the option. So option A is incorrect. Now let us go ahead. Second option. So we have to compare f of 1 upon 3 and f of 2 upon 3. 1 upon 3 lies here and 2 upon 3 lies here. So both lies in this particular region. So in this region, again f dash x is positive. So function is increasing. Therefore, f of 2 by 3 is greater than f of 1 by 3. Okay. So this is what we got. So the same thing is given in the options. So option B is correct. It is less than or equals to. So since we have this condition getting satisfied, so we can mark it correct. Alright. Next third option is f dash of 2 less than 0. F dash of 2. So let us check what is f dash of 2 from this. F dash of 2 is equal to f of 2. We know this is positive. In the beginning of the video, we have derived that f of x is positive. So this will be log, when you put x is equal to 2, it will be 3 upon 5. So that is, this is positive. So we have to check the sign of this. So this is simply log 3 minus log 5. Log 5 is bigger than log 3. So therefore this quantity is negative. So less than or equals to 0 is given. So C is also correct. So the correct options are B and C. So I hope you have got something to learn from this video. So we have dealt with different concepts in this video. The first thing is to notice that f of x is always positive. And the second thing is to manipulate and convert these products into summations. And the third thing is to put all the summations in the integral forms. And the fourth thing is to use Leibniz rule here to differentiate on both sides. And how did we get that idea? By seeing this particular option. Alright. And the fifth thing is to check the increasing and decreasing nature of the function depending on the sign of f dash of x. Alright. So these are all the concepts that are used in this particular question. So thanks for watching. And if you like the solution, hit that like button, share it with your friends, and subscribe for more such content.